Good morning, everyone who joined recently. My name is Alexander Adamov. I work in BTH in a professional master information security project called shortly PROMIS. And I would like to welcome you to the next episode of cybersecurity webinars, which is called Ransomware versus AI Part 1. And today we're going to talk about AV bypassing techniques used in targeted ransomware attacks. AV means antivirus or anti-malware solution. So what's the plan for today? So I would like to start with a short introduction to AI and ML to understand actually what it is and to define this sort, because there are a lot of speculations around AI, and we need to clearly understand what AI is and what is the relation between AI and ML. Then we go to AI approaches to detect ransomware attacks, and I'm going to show examples of targeted ransomware attacks that as seen in 2019 and 2020. And also I will highlight the bypassing techniques used in these targeted ransomware attacks. And in the end, we'll talk about this project, about courses we've been developing, and give you a hint how to apply to these courses. So, as I said, let's start from the definition of AI. On this diagram, you can see two concepts. The first one on the left is science fiction AI concept. Probably if you are a fan of TV series such as Black Mirror or Westworld, so you know that there is a concept that it is possible to create a robot or machine that will behave, will think, that will perceive in the same way as a human. And another concept is more like used in science and engineering. I call it applied AI. This means that we use AI as some technique and as some tool in our to solve our problems, to make our system more smart so they can make decisions like human, but of course it's not 100% human substitution. And the first concept is called artificial general intelligence, and I believe so we're still too far from implementing this concept into reality. So in this presentation we will be working within the second concept, applied AI, where machine learning is a subset of AI. And it is worth mentioning also 5 AI paradigms identified by David Auerbach, which is an American writer and former Microsoft and Google software engineer. So he proposed to split AI and machine learning era into 5 periods. Speculated before 1940, actually this is all ideas that were proposed mostly by philosophers, starting from Plato, where they imagined that they accept the possibilities to having intelligence out of the human body. Second is cybernetic. In this regard, we should recall John von Neumann with the self-reproducing machines concept, and of course Alan Turing, who wrote the basement of the modern machine learning and AI concept. Then symbolic AI and sub-symbolic AI. Symbolic AI is concept, is a term for the collection of all methods in the artificial intelligence research that are based on high-level symbolic human-readable representation of problems. And on the contrary, sub-symbolic AI proposes that assumes that we don't need to use human-readable symbols, but we can actually feed our AI models with the raw data. So if we talk about symbolic AI, it's more like decision trees, and if we talk about sub-symbolic AI, in here we can give an example It's perception methods, image, speech, voice, text recognition, and in this subsymbolic AI, we don't need to explain the machine, for example, what is image look like, but we just feed the pixels into the neural network. And finally, deep learning, which started its popularity since 2010, and still it's quite excellent. And deep learning is currently used widely to solve the perception task. Of course, this division is quite vague. And for example, if we talk about some symbolic AI, it actually started in 1958 with Frank Rosenblatt perceptron conception. So perceptron is a simple neural network. It's a simple machine that implements the idea of neural network. And it was created and was founded much time before actually the period of subsymbolic AI. And I would like to, in spite of the machine learning definition, I would like to highlight 5 major concept approaches in machine learning. So the first three are represented on the picture. You can see it on the right. Supervised learning, unsupervised learning, and reinforcement learning. But it is worth mentioning also 2 hybrid approaches, 2 more. It's semi-supervised learning and self-supervised learning. So semi-supervised learning is a hybrid approach, which is a mix of supervised and unsupervised, where we have some data labeled and some are not. And self-supervised is quite promising approach, where the idea that the AI model generates the labeled data itself. An example of such model can be, for example, when we have images, our AI model can rotate the images in arbitrary angle and then feed these rotated images as an input to be able to force the AI model to recognize the angle and rotate it back to the original state. So in such way, AI generates labeled data, and it also tries to solve these puzzles that it generates for itself. And another example is when images is cut into, for example, 9 pieces, and AI needs to actually solve the puzzle and put all 9 pieces into correct places, so we can get the original image. As for the supervised learning, we have a small problem. It's a problem about labeled data. So usually when you need to train for the big AI model, like that should as an input have a lot of data. So you need to provide a big amount of labeled data. And in this regard, so we have a problem how to generate this labeled data. So usually humans, engineers, they provide this labeling, and sometimes there is an automated solution, for example, CAPTCHA, when people are forced to prove that they are not robot to enter the system, and they need to solve the puzzle, classification puzzle, for example, to select like cars or buildings or whatever depicted on the pictures. And this information, this input can be used as a labeled data to train our AI models. So here we can see an example. I just have some problem with switching the slide. Just a second. Yeah, this is the slide for supervised learning, and yeah, on the picture on the picture, as you can see on the slide, there is a joke. To prove you are not a robot, specify the pictures with shelters where you are going to hide during the rise of the machines. So this is how AI can force humans to generate labeled data and to train the models. Unsupervised learning, on the contrary, doesn't require any labeled data. For example, on the diagram on the left, we have a labeled data, green and blue, and our task is to find such a function that will split this data into two classes with a minimal with minimizing the cost function. So usually logistic function used as a cost function in this case, and is if we have, for example, red dot that goes to the area with the blue dots, so it means we have an error. And our task in supervising classification is to minimize this error. On the right, we can see how unsupervised learning works. So we don't have labels on the data before. They're all gray. They're all similar to us, but we just calculate the distance between these dots, so we can group them between similarity of some attributes that we chose for our unsupervised learning. So this is more applicable for the task where we don't have much labeled data, and cybersecurity is one of them. And another one is number 3 is reinforcement learning. The idea is we have an environment, and we have an agent. So our task is to train our agent so that it will act in a way that will end up with the maximal reward. So usually this approach is used in games, in board games, for example, Go game, chess, and also in real-time strategies where we have a multi-agent simulation and multi-agent reinforcement learning is applied. So the idea is when agent performs an action, so we need to understand, the AI needs to understand how this action affects the environment, and if this action was successful or leads to some better position in terms of reward, or this action is bad and we should avoid it in the future. So to do that, we have an interpreter that provides reward for a particular state, and the state actually the new state that the environment was switched from the current state by the action, and this state is also provided by interpreter by analyzing the current state of the environment. I'm going to talk about reinforcement learning in the second part of this lecture because I have some proof of concept implemented to bypass cyber defense. And regarding the application, so it's not only board games, so reinforcement learning is applied also to robot control. And recently, like since 2018, I found the mention that reinforcement learning was also used in penetration testing, security testing, in particular penetration testing, and I use it in anti-malware testing. So let's come closer to ransomware detection. So what particular methods, machine learning methods, can be used to detect ransomware? The first class of methods is called anomaly detection. So here we have three major approaches: user and entity behavior analytics, UEBA, which represents the idea that we can analyze the behavior of the user or process or computer in network or in operating system based on the logs. So we can part of the logs, we can collect the events, and then we can find out if there is an anomaly in behavior based on the log events. This approach is widely used in SIEM system, Security Information Advanced Management solution, and they have extensions that allow you to connect your machine learning algorithms to process the data. Then honeypots, it's actually cannot be. This concept is between the machine learning and deterministic detection approaches, because honeypots it's special systems, special services that are deployed in corporate network, and if there is any request to honeypots, this is considered as anomaly. But the problem is, it's not a problem that makes it easy to use, that honeypots are not used at all. They shouldn't use at all. And if we have any connection to honeypots, this means this is done by intruders, and this is indication of an attack. So it's something between deterministic detection approaches and probabilistic detection approaches using machine learning.
Alex, did you check the slides? Did it change?
Yeah, there is.
Where the reinforcement learning slide?
Yeah.
Okay, great.
So I just described the user identity behavior analytics concepts, honeypots. Next one is anomalies in files contents. So we can actually take a look at the files and figure out if they have been encrypted recently based on some attributes, for example, modification, timestamp, entropy level of the data, if there is a magic signature inside of the file, or it was encrypted in case of it's encrypted, we will not find it. Then the next class of methods is reputation-based security and scoring system for applications. And here, so we can create a reputation model, so we can assign trust and risk score to entities of our environment. It can be users, it can be computers, and even applications. So based on the actions performed by these entities, we can adjust this reputation score, and based on that, if it crosses some threshold, so we can generate an alert and probably block this entity from performing the further actions. Next one is smart pattern matching, where we can find malicious code patterns in the process memory or finding ransomware artifacts in already encrypted files. This can be done, for example, by finding cryptographic primitives. So some specific set of data, specific numbers that are used in encryption, and we can find these patterns in the process memory. And about the advantages of unsupervised anomaly detection. So this is a preferable way to detect cyber attacks, because we don't need labeled data, and as a result, we can identify zero-day attacks as well as unknown security threats, because if we use supervised learning, so supervised learning aims at detecting already known cyber attacks. And in our case, the biggest problem is actually the attacks that we don't know. And those attacks are usually targeted, they are highly evasive, sophisticated, and we should provide some method that will find out the anomaly without any prior knowledge. Then unsupervised anomaly detection doesn't focus on specific class of threats and can be used to identify also data leakages as well as functional violation to predict system faults. So this is also useful to apply for safety violation detections, and other non-security issues. And here the list of anomaly detection algorithms you can find in Wikipedia. I'm not going to stop here, so you can find it and read more. As for behavior-based detection, so it's easier to anti-malware solutions to detect ransomware based on some behavior. So the examples of such behavior that can be seen in the light of anomalies is modification of more than n files by a single process in a specific period of time. So we can, for example, say, okay, if I have my files in documents folder changed in 1 or 2 minutes in a short period of time by a single process, so we can say probably this can be ransomware, or it can be a tool that we use to encrypt our files. Or it can be, for example, batch processing of the images. If you do, if you photographer and you want to, for example, adjust exposure in your photos, so you can start the batch script that will change these attributes. So of course, it is not protected against false positives when we have false alarms, but it helps to identify the threats in case the anti-malware solution has no signatures to detect this particular ransomware. Then writing data with high entropy. So when we pack or encrypt data, we increase entropy. So usually the encrypted data has an entropy which is greater 9.9. Of course, it depends on the file size, but this is more like a rule. And
Alex, sorry, I think there is no new slide.
Okay, it's again. I apologize. Yeah, here. So I was talking about entropy. So typically, if we have an entropy more than 9.9, so it can be a sign of data encrypted in encrypted data in the file. And if we have before, like all files having the entropy like around 4, 5, so for text file it can be lower than 4. And if encrypted, so we will get the entropy higher than 9.9, which is a sign of encryption. So we can create an algorithm that will analyze these anomalies using the entropy as an input data. Then adding the second extension, so ransomware usually add the double extension to distinguish the encrypted files from the other files. And when you, for example, pay ransom and get the decryptor search your file system and select the files with the specific extension, for example, enc or encrypted, or it can be some name of the family, for example, blocker. And in this case, if we have a picture like 1.png and adding the second extension will result in this file name. And this helps the decryptor to find out the files that were encrypted by this particular ransomware. And the last one that can be used to detect ransomware activity in your system is calling crypt API. So the conventional way to use cryptography in Microsoft Windows is to use using a Microsoft cryptographic provider. It's usually called like crypto API. So the cryptographic provider provides an ability to store the keys. So it's like a key manager, as well as it has implementation of the major crypto algorithms that you might need to use in your application. The thing is, all these requests can be monitored and logged, and the ransomware authors, they usually try to avoid using standard crypto API because this can be detected by anti-malware solutions. And I'm going to show how they avoid this detection. So let's switch to ransomware attacks. So here we have evolution of the ransomware provided by Sophos anti-malware company. So as you can see, this is a statistic for 2019. As you can see, in the beginning of the year, it was like in the beginning of the table, we can see that there is a WannaCry. It's not 2019, but the attack started in the beginning of 2017. And the specific of this ransomware was that it spread using Eternal Blue exploit, and the type of this ransomware was worm. It was mass ransomware attack. Then we have GenCrab. GenCrab is a ransomware family supposedly created by Russian programmers, and this is one of the first ransomware as a service solution. So when we have a separation of duties, segregation of duties between criminals and developers. So developers, they create ransomware code because it is needed to understand the cryptographic concepts. It is needed to understand how to create a malware code that will be not detected, and how to apply obfuscation encryption to the code. And the criminals who just use the code to attack users and get the ransom. Of course, they pay around 30% from the extortion money to the authors of the GenCrab. Then we have a period that was that can be called as a period of targeted attacks. SamSam, Harma, Bitpaymer, Rook, LockerGoga, and Megacortex are all ransomware that were used in targeted attacks, which means they are not distributed using exploit like a WannaCry. They are not sold on dark web as a GenCrab, but they were used by highly skilled hackers that first penetrate into the corporate environment. So usually they target big corporations, big companies, and then they continue running the attack and just establishing foothold and performing all other actions to get the control of the maximum amount of computers in the network, and then start encrypting the data on these computers, and then ask to pay like a very huge ransoms. And one of the examples is LockerGoga, that was famous because it managed to get out of operation Norsk Hydro IT system. It also attacked Altron Technologies and US-based chemical companies Hexagon and Momentive. So on the right, on the right, you can see the warning that was actually put on the window in internal Norsk Hydro environment, where they say like, we are under attack. Please do not connect any devices like your smartphones, your laptops to the corporate network, because there is a danger of being infected by LockerGoga. So it was the attack was successful, and it went the IT control system out of operation. Then Megacortex, supposedly created by the same authors, and it was run a little bit later in May 2019. 47 attacks were detected within 48 hours. So they ran this attack in the limited period of time to avoid being detected by antivirus solutions. And once this malware is detected, this ransomware is detected, so it will be blocked in all other companies and all other organizations. So time matters. in this case. Well, let's talk about bypassing techniques finally. The first technique is abusing code signing. So here you can see the diagram that I took from the article by Chronicle. Chronicle is a cybersecurity division of Google. Now it's a part of Google Cloud Security. So they actually gather the statistics of using certificates in cyber attacks. And as you can see, number one is a Komodo certificate authority that issued 1,775 certificates to attackers, and those certificates were used in the attack. And fake certificates were used in Locker Goga and Megacortex attacks. In Locker Goga, you can see the certificate issued to fake company called Alisa Ltd. In other samples, we managed to find other companies like Titis Ltd, Mickey Limited, AB Simba Limited. All these are fake companies registered in one place, and the address of these companies were used to issue the certificate. And the interesting peculiarity of this certificate that they were all registered for the same address in West End London with 84 and 673 other companies. So here you can see on the picture, this is a street view from Google. This is some office space in the West End where all these companies are registered. Supposedly they use some service, a registration service that use the same address. And as for Megacortex, so we have the same thing here. So the certificate was issued by Talte, and they also registered to some location in Romford. Romford is a suburb of London with 74,000 other companies. And regarding the detection, so conventional approach to detect malware doesn't work in this case because attackers, they use obfuscation, they use encryption to hide the code, and they also use this certificates. If application is signed with certificate, it doesn't attract attention from anti-malware solution. And you can see here on VirusTotal, there is a 0 detect out of 67 anti-malware solutions. Another trick to bypass anomaly detection and behavioral blockers of anti-malware solution is multi-process encryption. The idea is that we have a parent process that spawns the child processes. And so here we have 3 child processes. And every child process is responsible for encrypting limited number of files, like 1, 2, less than 10. So this is done because, as I said, many anti-malware solutions, they detect as anomaly when a single process detects, for example, more than 10 files in a single folder, and this is anomaly. But when you split the encryption into several processes, in Locker Goga, they use one process per one file. So when child process and the encryption, it terminates, and it spawns another child process. And the communication between the processes was done using shared memory objects. In Megacortex, they did pretty much similar thing, but they used they start DLLs. So you can see this is run DLL calls processes. They actually started by Megacortex, parent process, and every run DLL.exe loads malicious ransomware DLL and use it to encrypt the files. Again, the number of files is vary from 1 to 10 files. And another technique, custom cryptography. As I mentioned, crypto API is not the way how ransomware encrypts data, because it attracts a lot of attention from the Windows, from anti-malware solutions, because they monitor this request. And therefore, the ransomware authors, they started statically linking crypto libraries. So it means the code, the crypto code, the encryption code is embedded inside of the binary. So there is no any API call to DLL or to whatever operating system service responsible for cryptography. Still, it poses some, weaknesses in implementation, because the authors of ransomware, they do not use, they sometimes use their own implementation of cryptography, and this led to mistakes. And in this case, for example, instead of using a standard public exponent, which is 65,537, this is a maximum Fermat number, as you know. They used lowest Fermat number, which is 617. It's not a great big weakness in cryptography, but still that is not conventional cryptography. And this year, less than a month ago, on April 21, it was detected the attack by Ragnar Locker. They successfully attacked the network of Energias de Portugal and managed to steal 10 terabytes of sensitive company data, demanding a payment like a record, really one of the biggest ransom payment in the history. They asked to pay 1,580 bitcoins, which is approximately $11 million. So this is a new trend in the ransomware attack, in target ransomware attack. The attackers not only encrypt the data, but they also steal it and blackmail the organization that they're going to publish this information. Of course, when it comes to sensitive information, to keys, or to, I don't know, some financial or users' data, this is a quite unwilling situation, and that may result in penalties according to standards and privacy standards and regulation. Therefore, organizations prefer to pay, but if the sum is too big and there is no way to pay, so unfortunately there is nothing to do in that case. The interesting thing, how Ragnar Locker bypass anti-malware solutions. They deploy like minimal version of Oracle VirtualBox and started Windows XP virtual machine image. So this is called, I believe, mini Windows XP image. And the attack payload was 122 megabytes. And the ransomware payload was just 49 kilobytes. And here you can see the ransom note published by Sophos Lab, because they discovered this attack. If you're reading this message, then your network was penetrated, all of your files and data has been encrypted. Although your security measures already been breached and your files were locked, we was able to make a penetration of your network again. So probably this is a repetitive attempt to hack this organization. So in conclusion, I would like to state that the success factor of many ransomware attacks seen in 2019 as well as 2020 is mimicking behavior and appearance of benign applications. I mean, using the digital certificate, imitating the behavior of normal behavior of users regarding the file modifications, and so on. And this helps the attackers to bypass cyber defense. So I call it the imitation game. So this idea was initially proposed by Alan Turing in 1950, and the imitation game was the name of the test to identify if you are talking to computer, to a machine. And in this case, we can consider the imitation game between the attackers, the hackers, and anti-malware solution, because anti-malware solution in our case can be seen in the light of using AI technologies to stop the attack, to detect and stop the attack. In the next episode, I'm going to talk about Winston Churchill, Lysidol, and Mr. Agent, with whom we are going to create a perfect ransomware that will be able to bypass anti-malware solution with the help of reinforcement learning. And a few words about, okay, I'm again have stuck with slides. Yeah, this is Winston Churchill, Lysidol, and Mr. Agent that I talked about. And few words about the current projects that we are working on. We've been developing the courses for engineers, and these courses were about how to develop secure source that cannot be hacked or that cannot be exploited by the attackers. And we have university-grade courses that are specially designed for engineers, which means we try to create it condensed, so it will not take a lot of time from the employed engineers, and they are practical oriented, so you can get hands-on experience and apply it to your professional area. As for the courses, so the first course is security in software-intensive products and service development. Here we focus on technologies, on software development lifecycle, and how to embed security aspects into software development. Software security is a course that aims at showing you how to hack your applications as well as to protect it against potential hack. Web system security is the same but for web systems, so it explains the potential attack vectors on web services and how to protect, how to make it attack, how to protect against potential attacks from the hackers. And if you want to apply for one of these courses or all of them, so there is a guideline that I believe you can read from the slides that will be shared after this presentation. So thank you very much, and if we have any questions, I will be happy to answer.